Jai Hind, myself Dr. Alok Vardhan. Currently, I am working as an assistant professor in the Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. Today, I will discuss one of the important topics of the subject fundamentals of mechanical engineering. In this lecture, I will discuss about what is air conditioning, their applications, then construction and working of Windows type air conditioning, then some numerical problems related to refrigeration and air conditioning. So, first of all, I will discuss what is air conditioning. So, basically air conditioning is the process of treating air to control its temperature, humidity, purity and distribution to meet the desired indoor comfort या industrial conditions. Air conditioning involves heating, cooling, humidifying, dehumidifying, filtering and circulating the air. Then what are the applications of air conditioning? The first application is residential building to maintain indoor comfort. Then commercial spaces like offices, shopping malls, theaters. Then industrial applications like precision manufacturing, pharmaceuticals, etc. In hospitals to maintain sterile and controlled environments. In automobiles, climate control for comfort, and in data centers to cool servers and electronic equipment. So, these are the applications areas where air conditioning used. Then I will discuss some important definitions regarding the air conditioning. So, the first one is dry air. What is dry air? The atmospheric air with no water vapor is called dry air. The atmospheric air with no water vapor content is called dry air. Then what is psychrometric? Basically the study of properties of the atmospheric air is called psychrometric. Then what is temperature? The degree of hotness or coldness. The degree of hotness or coldness is called temperature. Then another important definition is what is humidity, also known as specific humidity or humidity ratio. It is mass of water vapor present in 1 kg of dry air is called humidity या specific humidity या humidity ratio. Then what is absolute humidity? It is defined as mass of water vapor present in 1 cubic meter of dry air is called absolute humidity. Basically humidity is further classified into two types, absolute and relative. So what is absolute? Absolute means mass of water vapor present in 1 cubic meter of dry air. Then what is relative humidity? It is the ratio of actual mass of water vapor in a given volume to the mass of water vapor actually can withhold by the same volume is called relative humidity. In percentage, relative humidity is equal to amount of water vapor mass present in air divided by amount of water vapor needed for saturation into 100 is called relative humidity in percentage. Then what is dry bulb temperature? The temperature of air measured by the ordinary thermometer. Basically the temperature of air measured by the ordinary thermometer is called dry bulb temperature. Then what is wet bulb temperature? So the temperature of air measured by the thermometer when it is covered by the wet cloth is known as wet bulb temperature. Then last one is, what is dew point temperature? Basically, the dew point temperature is the temperature at which the water vapor start condensing is called dew point temperature. Then what is comfort conditions? Basically, comfort conditions refer to the indoor conditions that make human feel thermally comfortable. Means neither hot nor cold and not too dry or humid. The key parameters of comfort conditions are, first one is temperature. Usually between 22 degrees Celsius to 26 degrees Celsius depending on region and season. Then relative humidity between 40% to 60% is considered comfortable. Too low means, if relative humidity is too low, dry skin problem, throat irritation problem, and if it is too high, sweating and discomfort problem. Then third one is air velocity. So slight air movement like 0.15 to 0.25 meter per second enhances comfort. Too fast air velocity problems, draft and discomfort. Then air quality, low concentration of dust, pollutants and allergies. Fresh air ventilation is essential. And last one is noise level. Low noise level acceptable is 25 to 45 decibel. Improve comfort, especially in offices and home. So these are the key parameters for comfort conditions. So this is the important definitions regarding air conditioning system. Now I will discuss types of air conditioning. So basically there are three types of air conditioning: window type, split type and central type. So in our syllabus there is only window type air conditioning system. So in further slide I will discuss about window type air conditioning in detail. So what is, first of all I will discuss what is window air conditioning, window air conditioner, their working, their construction and working. So basically a window air conditioner is a single unit system with all components housed in a single casing. It is mounted on a window or through a wall. The main components are compressor. It compresses the refrigerant and increases its pressure and temperature. Then condenser coil cools the high pressure refrigerant gas into a liquid by releasing heat. Then expansion device like capillary tube or expansion valve lowers the pressure and temperature of the liquid refrigerant. Then evaporator coil absorbs heat from the indoor air, refrigerant evaporates and cool the air. Then next one is blower fan indoor, circulate indoor air over the evaporator coil and back into the room. Then fan outdoor unit, draw outside air over the condenser coil to dissipate heat. Then filter, trap dust and particles from incoming air. Then thermostat controls the temperature by regulating compressor operation. Then drain tray and pipe collects and removes condensate. And last one is housing a cabinet, contains all components and provide insulation and mounting support. So these are the components of a domestic air conditioning, window type air conditioning system. Now this is the schematic representation of a window air conditioning system. This is thermostat, this is evaporator coil, this is drain tray, this is filter, this is blower for indoor unit, this is fan for outdoor unit, this is condenser coil and this is expansion device like capillary tube, expansion valve, capillary tube, throttling device, and this is compressor. This assembly is outdoor and this is indoor side. Okay. What is working? So basically the working of window AC is based on the vapor compression refrigeration cycle, which consists of 4 main processes. The process 1 is compression. In the compressor, the low pressure refrigerant vapor from the evaporators enter the compressor, where it is compressed to a high pressure and temperature. Then it goes in condenser coil. So the second process is condensation. The high pressure hot refrigerant passes through the condenser coil, where outdoor air blows over the coil via fan, and the refrigerant releases heat and condenses into a high pressure liquid. Then third is expansion valve, a capillary tube. In this, the high pressure liquid refrigerant flows through an expansion valve where its pressure and temperature drop significantly. Then the last process is evaporation. So in this, the low pressure cold refrigerant enters the evaporator coil, where indoor air blows over the coil, and the refrigerant absorbs heat from the room air and evaporates, cooling the air, which is then blown back into the room. Further, this cycle repeats and the evaporated refrigerant returns to the compressor and the cycle continues. Now, I will discuss some important numerical problems related to refrigeration and air conditioning. So, in this problem, a cold storage is to maintained at -5 degrees Celsius while the surroundings are at 35 degrees Celsius. The heat leakage from the surroundings into the cold storage is estimated to be 29 kilowatt, and the actual COP of the refrigeration plant is 1/3 of an ideal plant working between same temperatures. Find the power required to drive the plant. So basically, first of all, we will draw the diagram of this refrigerator. So basically, this is refrigerator, this is source, the temperature of source is 308 Kelvin and the temperature of sink is 268 Kelvin. The power required to drive this refrigerator is W, and the cooling effect is 29 kilowatt. So we know that COP of refrigerator is equal to desired effect, means cooling effect divided by work input. So here in problem it is given that COP actual is equal to 1/3 of COP ideal. So first of all we will calculate what is COP ideal. So by using temperature formula, like COP of ideal is equal to T lower upon T higher minus T lower. First of all, we will calculate the coefficient of performance in ideal condition. So its value is 6.7. Then we know that COP of actual is equal to 1/3 of COP of ideal. So we will calculate COP of actual, and it is 2.23. Then we know that COP of actual is equal to desired effect upon work input. So from here we can calculate W, and W is equal to 13 kilowatt. So therefore power required to drive this plant means W is equal to 13 kilowatt. So this is problem number 2. In this problem, an inventor claims to have developed a refrigerator working between 1000 degrees Celsius to 500 degrees Celsius. Each refrigerator extracts 200 kilojoule heat from the sink and consumes 40 kilojoule work. Justify the claim of the inventor. So first of all, we will calculate COP, coefficient of performance in ideal condition, by using this formula, यानी कि T lower upon T higher minus T lower. Further, we will calculate COP of this actual refrigerator by using this formula, QL upon Q higher minus Q lower. And if COP of actual is less than COP of ideal, so we can say that the inventor claim is feasible. And if COP of actual is greater than COP of ideal or theoretical, so we can say that this claim is infeasible. So here COP of actual is 5 and COP of ideal is 1.546, means actual COP is greater than ideal COP. It means the inventor claim is not valid or not feasible. So this is all about for this lecture.